Good afternoon. I'd like to introduce you to Kathy Reid, and she's going to be talking to us about less flack and more hack. This is apparently a very interesting talk because she was practicing last night, and we'll all find out about spruiking up our conference t-shirts. Thanks, Kathy.
Thanks very much, Robin. First of all, can everyone hear me okay up the back? Fabulous. Excellent. Well, thank you all for choosing to come to my talk. There's a large number of very high calibre talks on at the moment, so thank you for making a choice to come and see my talk. Big thank you to Robin and to Bianca for organising the HackScene conference, and I'd also like you to put your hands together for our very hard-working volunteers up the back who've... The work that you do is very much appreciated and often very hidden. So my name's Kathy Reid. I'm Kathy Reid on Twitter, on GitHub, on IRC, everywhere. My day job is at a Victorian university doing whatever my boss wants me to do. It might be video conferencing or digital or web or stuff. But what I do outside of work is a real passion. I'm really into knitting, and it's fantastic to see so many yarn artists here today. I'm into knitting and I'm into technology. And what I'd like to do today is take you on a journey on the intersection between those two passions. So this quote means a lot to me. It's from a writer who actually wrote under a male pen name. I won't go into the politics of that here. There are people much more qualified to talk about that than I am. But it's about the strongest principle of growth lies in the human choice. Life always presents us with choices. Sometimes those choices are easy: black, white, tea, coffee. Actually, that's not a choice. Aussie rules or soccer. Generally, though, those choices are a little bit more nuanced. And the same is true for technology and the way that we choose to interact with it. We make choices about technology every day, whether we're conscious of them or not. Which operating system to use, which software to use, all completely free and open source. iPhone or Android, which tablet, how much to share or not to share, or when to turn off from technology. What we're perhaps not so conscious of yet, though, is that it's becoming easier to make and modify our own technology. If we're not happy with how something works, we have the choice to make it better. We can void the warranty and we can hack it. We can choose to improve it. Realising that you have a choice is a difference between breaking free of your constraints or having somebody else determine your future. Now, I think I get bonus points for getting bacon into my presentation, albeit in a roundabout way. So, what does this all mean in terms of technology? It means that we choose that we want to have more control over technology, and we need the tools to be able to exert that control. So in the open hardware scene, we're seeing adoption of 3D printers like MakerBots, RepRaps, that type of thing. In the home automation scene, we're using tools like Arduino, Zigbee, and I don't know if anyone's heard of the Ninja Blocks. No? Come talk to me about Ninja Blocks. My Ninja Blocks are shipping from Hong Kong. I'm so excited I'm getting Ninja Blocks. Calm down. They're carving out a niche that used to be filled with things, proprietary technology like AMX and Extron and proprietary stuff. But what about crafting and textiles? How does this help me as a knitter, as someone who likes working with fabric and yarn? Oh, yarn, I love yarn. How does this all help me? Enter LilyPad Arduino. Do we have any Arduino fans, users? Excellent. So, LilyPad Arduino was designed by a lady called Leah Buckley, and it's designed to foster the development of electronic textiles. Smart crafting with sensors, lights, really anything you can imagine. You can even use LilyPad Arduino to create interactive jewellery. So, what do you need to get started with LilyPad development? I'm going to walk you through it. Or as I love to say, So I built one. And I'll switch back to the document camera when we're okay to do that. But I did just want to run you through the code behind the light scarf. I'm a PHP programmer by training, and the Arduino IDE environment runs on something that looks like C. So if you've done any programming previously, you're probably going to be quite comfortable in an Arduino environment. So with the light detecting scarf, basically all we do here is initialise some pins on the main board, and we tell them here that we want to read a particular parameter on one of the pins, and that we want to push out an output to some of the pins. So this is what this code is doing. It's basically telling the Arduino LilyPad board, I want my sensor pin to be this pin, and I want you to set these pins as output pins because I'm going to put an LED on the end of them. Then what this code on the bottom is doing, is basically running in a loop. So the temperature sensor on the light scarf, and I'll flick back in a minute, the temperature sensor on the light scarf, every whatever timing I set it, reads the light value, the ambient light value. And if it drops below a particular threshold, what that code is saying, I want you to write out to the pins that I've set are my output pins and turn on some LEDs for me. And then check and see what the light's like again, and if the light's low, keep the LEDs on, or if the lights come back on, turn the LEDs off because we don't need the LEDs anymore. This took me about 3 hours to create the code, get the LilyPad components together and sew it in. I don't have hours and hours to play with this stuff. My time's quite limited. So this was a really, really fun, easy, quick project to do. And I feel that a little bit safer when I go through Geelong at night with my LED light scarf. So how does it all work? Am I okay to flick back to the doc cam? The thought process behind the temperature sensing beanie went something like this. For those of you who know me well, you know that I had a particular medical challenge a couple of years ago, and during that period in my life I was very susceptible to infections, and I actually had a very nasty infection on board, and my temperature reached 43 degrees. That's considered life-threatening. I didn't realise that I was in danger at all until I presented with a fever of nearly 41 degrees. I felt okay. 42 started to knock me around, but I felt generally okay. What I didn't realise was that my temperature was just going through the roof. And I thought, well, if this happened in the future, surely there's some sort of technology or some sort of way, short of keeping a digital thermometer in my mouth, that I can measure my temperature and alert somebody if I'm not feeling very well. And I thought, wouldn't it be awesome to try and achieve this with LilyPad Arduino? And that's where the idea of the temperature sensing beanie came along. Could I sense the temperature of somebody's skin temperature and take some action based on that input? This is a project under development. I haven't actually been able to achieve my goal. I haven't been able to accomplish what I set out to do, but I'm about 60% of the way there. So it's all steps in the right direction. So what the temperature sensing beanie tries to do is basically set up a series of temperature sensors. They're thermistor type temperature sensors. There's 3 of them in the design, although the design's done in a way that we could add more in the future if we needed them. And what it tries to do is take a number of readings, average them out to get higher precision, look at those readings, and then take action like turn on a bright LED if they're above or below a certain threshold. So that's what this code is doing. It just defines some RGB values there for common colours and defines some colour transitions for the RGB LED. Excuse me. And then this code here, what this code is doing is basically running in a loop. It's doing a temperature sense from the thermistor, from the temperature sensors. It's running some mathematical calculations on that sensor reading, and then it's determining what to do with that output. So in this case, what it tries to do is turn on an LED. If that temperature is above a certain range, it can blink the LED to let anybody know, hey, you're blinking. We might just want to take your temperature and see how you're feeling and get you into this ambulance. So this is what the code is trying to do. Now, I had some really tough implementation challenges with this. The last time I did electronics was in about year 10, which is, I won't give away my age, but it's quite a long time ago. Trying to relearn some of that stuff is a bit of a cognitive challenge, but the key challenge that I had here was trying to get a defined voltage. The temperature reading, the temperature sensor works off voltage. So it tries to calculate the temperature based on the voltage that it's receiving. If you don't have a defined baseline voltage, you can't take an accurate calculation of temperature. Now, if you're trying to calculate a temperature to take action on what might be life-threatening, you require at least some degree of precision. The documented voltage, my documented reference voltage, I didn't trust. So I actually got out my multimeter and actually checked the voltage, and it varied by about 25% to the documented voltage that I should be getting. So that's a key challenge. I don't know how to establish a good baseline voltage for the type of temperature sensors that we're using in this project. And I had to do some maths, which is a bit scary, but I got through it, to do the temperature calculations. So I'm not all of the way there yet, but I'm about 60% of the way to doing a temperature sensing beanie. It's a very, very basic introductory level projects. I spent a little bit of time on this one just because it's a bit of a challenge. But again, it's, you know, it's part of the way there. So, what does this all mean? If you're looking at e-textiles, if this is an area that you're very passionate about, what I'd like to do is invite you to make a choice. Make a conscious choice to exercise your imagination using open source e-textiles. All of this stuff, apart from the componentry, is completely freely available. The code is there. If you want to copy it, have a go. It's all there ready and waiting to be, waiting to have some imagination applied. Finally, what I'd like to do is leave you with a couple of possibilities. Possibilities that might actually save people's lives or improve society and humanity as a whole. I know there's not that many Victorians in the audience, but in Victoria we've had a couple of really nasty cases recently where autistic children have been able to get out of their home environment. Unfortunately, a number of them have died because they've come into the way of water or lakes or that sort of thing. Thank you. Imagine a world where we could put a jumper that's comfortable onto an autistic child, and ethical considerations aside, imagine if we could track them before they get to the water. Imagine if we had some sort of beanie, some sort of sensor that could measure the heart rate of a baby to say, hang on, I can't get a heart rate. Mum, Dad, come and help me. Imagine a world where, sorry, I've got a third one, I just can't remember what it is. That must be a coffee temperature sensing Arduino project in my future. Now imagine fabric that tells you what your heart rate is. Do we have any joggers? Anyone on the running boff? Awesome. Imagine if we had fabric that tells you what your heart rate is, or if you're running upstairs and you want to, make sure your fitness level is good. That's now possible. I've got a little component here called a pulse sensor, which can actually measure heart rate via Arduino and take measures in response to that. So you could have a meter on your t-shirt that shows what your heart rate is. People who have cardiac arrhythmias, we're getting to the point where a lot of this technology is open source, much more available. Many eyes, problems become very shallow. So in conclusion, please make an active choice. Imagine what's possible and what can be created with e-textiles. Thank you very much. Questions? Heckling? Rotten fruit?
How do you go with your scarf in a shower of rain?
Okay, very good question. Basically, this is what happens to it. You can see here that what's happened, what I'm just demonstrating at the moment, and for the benefit of the microphone, the question was what happens to the scarf when it rains. The issue that we've here is that the I didn't think of that.
Iron-on Vilene, or just to cover the components. I could make a pocket at the bottom of the scarf, or you could put something like probably not iron-on Vilene, but any of the interfacings.
Ah, that's a great idea. Thank you.
And you could line that pocket with something more water resistant than the scarf.
See, this is fantastic. I'm getting refactoring ideas from my audience. This is brilliant. Water resistant.
I'm not so much of a programming nut. Do you have your programs available somewhere on the internet?
Absolutely. I'm Kathy Reid on GitHub. Just search for Kathy Reid, one word. All of the code I've shown you today is freely available under a CC BY license. If that's not open enough, come have a chat to me. If you need me to take any BY restrictions off, let me know. I want this code out there. I want this code doing good.
Yeah, just to cover it, there's a thing called Plastomake, and it's plastic, and you just pop it in some hot water and then let it hardens, and you can create all kinds of plastic objects. So regarding reprogrammability or reuse of components, you just warm it up again and the plastic becomes malleable. So that's Plastomake.
Oh, fantastic. Thanks, Miriam. Great idea. I did have one question when I did the practice session with a group of people last night. Thank you for coming to the practice session and helping me polish this presentation. The question was around what is the composition of the conductive thread? And generally, I went back and did some research about this. Generally, the conductive thread is made of stainless steel, and it's a large percentage of stainless steel. So if you have issues with stainless steel, there's an alternative product on the market which uses silver plated instead of stainless steel. So there's alternative products available. Thanks everyone, and I'll hand over to Fee.
Your microphone.